Hello everyone, my name is Nikhil Mourya and I am here along with my teammates Vinay Agrahari, Zalavadiya Dishil and Venugopal Venkat. We are here today to present our work for assignment 5 of Mechanism Sessional. So, our project is the design and simulation of a mechanized door opening mechanism for a dumper truck. We are taking you through our design process for identifying the need, selecting a linkage mechanism, and performing the kinematic calculations, and finally showing you our simulation results for validation. So, the truck facing a major issue. The rear door is gravity driven and requires manual unlocking before the material can be dumped. The manual process is a time consuming, inefficient, and critically unsafe. So, our goal is to engineer the tricks out, and we designed a mechanism system that automatically opens as the bin tilts and closes when it returns, ensuring controlled and safe operation. So, I will hand over to my friend Dishil. He will take you over to mechanisms.
We decompose the problem into two focused subsystems to streamline the overall mechanism. First of all, we'll go through the lifting mechanism. Our system deploys a planar 5-bar mechanism that creates a controlled and synchronized lifting motion. The mechanism consists of the frame, an input piston, a coupler, the bin link, and a connecting link. These are connected through 6 revolute joints and 1 prismatic joints, which operates through the actuator. The actuator provides a linear input, and this linear displacement is converted into angular rotation of the bin. This transformation gives up to a smooth and predictable tilt motion from 0 degree up to approximately 30 degrees, which is suitable for dumping operations. We will go through the calculations and simulations of this lifting mechanism later part of this presentation. Now we will shift to the door mechanism. The door operates through a planar 4-bar linkage which mechanically ties the door to the motion of the bin. This means no sensors, hydraulics or electronics are required, just pure mechanical synchronization. This 4-bar system uses 4 revolute joints and creates a single degree of freedom linkage that ensures the rear door opens automatically as the bin tilts. The linkage converts the bin's angular displacement into coordinated angular opening of the door. Now I will hand over to Vinay.
So first, let us look at the bin and its linkage dimension, which were modeled and assembled in SolidWorks to conduct a detailed motion analysis. All link lengths shown in the diagram on the right were carefully chosen to ensure two key outcomes. The first one is smooth and interference-free motion and a realistic and reliable build tilt angle. This bin mechanism is connected via a coupling arm to the door mechanism. This coupling is designed to translate the bin tilt into the required maximum door opening angle. The base pivot position was strategically selected to eliminate interference and to avoid any dead center locking scenario, ensuring consistent and reliable operation. Now moving to the door opening mechanism. So it is associated with 4-bar linkage dimension, which was served as essential input for all subsequent calculation. So from the SolidWorks model, the length of the link are L1 to be 51.23 mm, L2 to be 95 mm, L3 to be 20 mm, and L4 to be 87.77 mm. So applying the Grashof criterion, S plus L that is less than or equals to P plus Q, we find out that the condition is satisfied, and this confirms that the mechanism behaves as a crank rocker. Another critical decision consideration was the dead center condition, which occur when the input and the coupler link become collinear, causing the mechanism to lock. We avoid this issue by introducing a slight pivot offset of 20 mm. Our final design objective was to design the functional relationship, that is theta door to be equals to the function of theta bin, that we obtained numerically from the simulation. Now moving to the next slide, our simulation is supported by the displacement analysis, which establishes the angle relationship within the 4-bar mechanism. This trigonometric equation defines how each link in the door mechanism move relative to its corresponding angle. On the right, we see the resulting plot between the bin angle and the gate opening angle. The response is nearly linear. A bin rotation of approximately 20 degrees result in a gate opening angle of about 45 degrees. This plot validates our design, confirming that a small and controlled input rotation from the motion is sufficient to achieve the required gate opening. The animation frame of the door opening mechanism are also shown, where link 4 is highlighted in green, link 2 is in blue, and the actual gate panel shown is in black color. The maximum gate opening angle obtained is 45, corresponding to the bin angle of approximately 20 degree. Now I will hand over the further presentation to my friend Venugopal.
The CAD model was made in SolidWorks where different parts were assembled individually and then assembled. The door opening mechanism depends on the lifting mechanism of the dumper truck where it opens gradually till a maximum angle of 55 degree. Let us now look at the animation of both the interconnected mechanisms obtained from the SolidWorks. We can see here the door opens as the bin rises. These are the different parts that were consolidated to make the final assembly. Now let me walk through the process of making the CAD. First, a sketch was made to take the dimensions of the lifting mechanism. This was done by the research paper that was mentioned earlier. Then a 2D prototype was made demonstrating the process of lifting and opening. We will now see the animation of it. Now the final CAD model will be showed. This is the final CAD model which was made after assembling different parts. If I hide the pilot cabin, you can see the part more clearly. The lifting mechanism was made after extruding different geometries. The lifting part consists of revolute joints and one sliding pair, which controls the whole mechanism. So there is one actuator which controls the whole mechanism. The gate opening mechanism also has revolute joints, and you can see how it is moving. In this project, we successfully designed and simulated a fully automatic door opening mechanism for a dumper truck using a combination of 5-bar and 4-bar linkages. The system ensures smooth synchronized motion between the bin tilt and door opening, eliminating manual effort and improving safety and efficiency. Our simulations confirm stable operation, no dead center locking, and reliable automatic locking when the bin returns to its original position. Overall, the mechanism offers a practical, low maintenance, and industry ready solution for modern dumping systems. Thank you.